Hi, everybody. This is Mr. Folly, and welcome to podcast 10.4, the last of the 10s. We're going to talk about colligative properties, how they change boiling point, melting point, and a few other things. The Van Hoff factor, and how we can calculate MM, which is molar mass. So let's go ahead and hop into that. Okay. Colligative properties. Doesn't matter what the substance is, just how much. Now, this happens in chemistry. We use it every once in a while, but there's not too many times when you see it in like regular life. Elections are one place. So if all the dumb people voted for David and all the smart people vote for Meggie, Meggie loses. Why? And it's not because Lauren, Vivian, and Madeline were starting fires to stop voting. So why would that happen? Oh, because there's just more dumb people. So votes are equal. Dumb people's votes equals smart people's votes. Oh, so that happens that way. There are three main places this happens in chemistry. And we'll go start part one. Freezing point depression is a colligative property. Okay, so a colligative property, again, is something where it doesn't matter the identity of it, just how much. Ions make ice freeze at a lower temperature. Any ions do it. That's why it's colligative. Why? Ions disrupt crystal formation, so it takes more extreme temperatures to freeze. So delta T equals I times K sub F times molality. Molality, remember, is mass over molar mass. Well, it's moles over kilograms of solvent, right? So molality is mass over molar mass, because this right here is moles, right? Over kilograms of solvent. So delta T equals I times K sub F times mass. Oops, I forgot my A. Over molar mass over kilograms of solvent. Okay. Delta T is the change in the freezing point. I is the Van Hoff factor, which is the number of particles, which is kind of like the number of ions. MM is molar mass, which is your go to the periodic table number. Okay. Van Hoff is I is the number of particles, but usually it's the ions. NaCl has two. Look, there's one Na and one Cl, and that equals 2. Calcium chloride, 1 calcium, 2 chlorines, makes 3. Sugar has I equals 1. Okay, that's not an ion because sugar is C6H12O6 or something like that. Notice how it's not an ion, so it's going to be 1. 5.50 gram sample of a compound dissolved in 250 grams of benzene. The freezing point of the solution is 1.02 below that of pure benzene. What is the molar mass of this compound? Delta T equals I times K times mass over molar mass, kilograms of solvent. So, the freezing point of the solution is 1.02 degrees below that of pure benzene. That means my change in freezing point is 1.02. The I of compound freezing point. Oh, by the way, if I don't tell you, if not told, I equals 1. So it's a compound, you don't know what it is. So I have 1 times K, 5.12, times the mass of the solute, that's 5.50, over the molar mass, which is what I'm solving for. And then kilograms of solvent would be 0.250. I'm looking to solve for molar mass, so I'm going to cross multiply and get molar mass by itself. Molar mass equals 1 times 5.12 times 5.5 divided by 1.02 divided by 0.250. And now it's off to the calculators. So molar mass equals 5.12 times 5.5 divided by 1.02 divided by 0.25 is 110.4 grams per mole. You should know that's the mass of molar mass. That's the unit for molar mass, not the mass of it. Boiling point elevation. This is also, by the way, kind of the same thing. Point number 1. So boiling point elevation. Ions make the boiling point go up. Why? ions are attractive, so it takes a more extreme temperature So one of the formulas is delta equals I times Kb times molality. But remember, molality is mass over molar mass kilograms solvent. So delta T equals I times K times mass of solute over the molar mass and over the kilograms of solvent. So notice that this is almost exactly the same. Delta T is change in the, made a boo-boo, boiling point. I equals Van't Hoff, and molar mass equals your go to the periodic table number. Determine the change in boiling point for 300 grams of carbon disulfide. Now notice carbon disulfide is CS2, not ionic. Why is it not ionic? It starts with a non-metal, so it'll share its electrons. If 35 grams of a non-volatile, non-ionizing compound is dissolved in it, well, I guess first of all that's the solvent, so I made a boo-boo. This is my solvent. So I don't care if that ionizes or not. But if it's non-ionizing, that means I equals 1. The molar mass of the compound is 70, and the boiling point of pure carbon disulfide is 46.2. So I'm looking for the change in boiling point. So I'm looking for delta T, which is going to equal I, that non-ionizing part. Well, delta T equals I times Kb times mass over molar mass, kilograms of solvent. And remember, that top mass is solute. Determine the change in boiling point, that's delta T. I, it's non-ionizing, is 1. Kb is 2.34. Mass, the solute, little part is 35. Molar mass of the compound is 70. Kilograms of solvent, 300 grams. Move the decimal 3 places, 0.300. Let's take a look and see what my calculator told me that is. 2.34 times 35 divided by 70 divided by 0.3 is, delta T is 3.9. So 3.9 degrees, and we're talking about boiling, higher. Okay. Vapor pressure. This is the second one that's a little bit different. Vapor pressure. Solvents are very attracted to solutes, to any solutes. Hey, that word any means it's a colligative property. So if there are solutes, the solvents will evaporate less. So there should be, I don't know if you guys can see this or not, but there should be different colored particles in here that are very attractive, that keeps these blue particles staying here because they're so attractive. Okay. Over here there's less attractive particles, so they evaporate more. Doesn't matter what they are, just that. And we don't have to do the math with that at all. Osmotic pressure. Solvents are so attracted to the solutes they will cross semi-permeable membranes. That semi-permeable membrane, what a semi-permeable membrane is something that allows water to cross, but not ions. Remember, ions are so attractive, right? So these are your ions. They're so attractive that these things, there's a force of attraction that pulls them in there. Beware the force. And that force can be calculated, although we don't calculate the pressure, by looking at the difference in the height of the tube. So that's osmotic pressure. Review. Boiling points go up. Things don't want to leave, right? And freezing points go down. Disrupts crystal formation. You can solve for molar mass with boiling point elevation and freezing point depression equation. Vapor pressure and osmotic pressures are colligative too, because the solvent is so attracted to the solute. But we don't do any math with that, so we'll be sad and just melt and not do math. Toodles.